Hello, everyone. Welcome to another session number 2 of the Civo DevOps Bootcamp. Let us know from where you are joining in the chat. We just crossed 2,000 subscribers on the Civo YouTube channel. That's pretty great. And today we have another session. And in this session, we're going to be giving you all an introduction to containers. So we're going to starting from the scratch. We're going to be seeing what are containers and why we might want to use those, how to, various tools compare to each other, and we'll look into a hands-on demo. I'll try to Dockerize, I'll try to add in simple language, I'll try to add Docker in like a simple project so you know how to Dockerize your own application. So a lot of hands-on stuff will be going on over here. We'll also do a what is it? An introduction to the architecture. So like how these things work internally. Um, so yeah, let's get started. And we also have a guest joining us today, Alistair. So he's also going to be sharing a little bit about containers and containerd and how these both compare. So thanks a lot for joining, Alistair. Really appreciate it. How are you doing today?
Yeah, I'm good, thank you. Looking forward to sharing some of my knowledge. So it should be good fun.
Awesome.
Thanks for joining.
Cool. Alrighty, so we'll start with that presentation after this one on containerd. But let me just quickly share my screen and. Believe you all are able to see. Cool. Alrighty. You know what? Let me just also add a nice little. Let me add a nice little story. You can also share this on socials if you learn something new. So this is, by the way, a lot of people were asking. A lot of people are asking regarding the DevOps Bootcamp. So this is the second session, and from now on we'll be doing like a lot more DevOps related stuff. Like the first one was the introduction one. From now on we'll be doing like individual things that we discussed previously. So you can see all the details in our kickoff session. So we did a kickoff session, and if you go to the Civo YouTube, there's a playlist that is known as the bootcamp. So over there, all the videos will be uploaded, announcement videos and everything are uploaded over there. So all in one place. If you are looking for on the Civo YouTube's playlist section, you can find it over there. And also in that intro video in the description, you can find the blog about this, and all the dates and everything will update it over there. From today's session, there's also going to be like a nice quiz. So after this session, you can check your knowledge and what you learned and all these things with a nice quiz. And that quiz is in the description of this particular video only. So if you check the description of this video, there's a Google form quiz, and there are like 10 questions that you can answer. And after this session, you can take that quiz, and we'll be having a quiz for every session now. And by the end of the boot camp, we'll be reaching out to some of the people who scored, let's say, the highest or something for some swag subject to availability. Well, let's get started with this session. Let me just check if everything is good on the stream. And if you have any questions, just let us know in the chat, and we'll be more than happy to answer. Yeah, if you're a beginner, you can definitely understand this session. Do not worry. And kindly only send your question once. Otherwise, the important questions get missed. So in order for us to answer every question, I'll just send your question once. Otherwise, I'll have to turn on the slow mode like last time we got so many questions. So yeah, just send in your question once, and in the end, I'll also be answering all the questions live. So agenda for this talk, my talk, and after that we'll have Alistair presenting as well. So here we're talking about like Docker and containers in general. What are containers? What is Docker? Why would we want to use Docker? How does it work? What is the architecture and the components, and a little bit of a demo as well. So what is Docker? Docker for beginners. So if I'm thinking from a beginner's point of view, let's first look at the definition. So definition says it's a container platform that allows us to build, test, and deploy applications quickly. But that is not what I want to explain, because it's a beginner-friendly session, like I promised. Like we are promising that no prerequisites for this session as such. So imagine that. Imagine you created an application. You made a nice website, okay, and you're running it on your system, or you made a nice application, an app you made, and you're running it on your system, and it's working fine on your system. And then you share that application to your friend. You share the code and everything to your friend. You're like, hey, dude, I made this application. Try it out. Let me know how it is. And your friend is like, it's not working on my machine. this saying this thing is missing, library is missing, version is out of date, or whatever. Now, then you might be saying the very famous thing, which is it works on my machine. So the idea for Docker is to one of the ways to solve this problem. We can use Docker for that, but let's look more into the intuition side, like what we are doing actually over here. So imagine that, let's say you want to ship a lot of things. You want to ship a car, a barrel, a piano, and all these things. Okay, you want to ship it from one country to another country, and you might be wondering, okay, how do I ship this car? And this is a different type of good. This is a food item. This is some other item. So a solution for this can be, if you want to ship it from, let's say, from London to India or whatever, you can put all of these things inside a box, and you can ship this box as a whole. The shipping company who is shipping the box, they don't care what is inside the box. They are just moving it from one place to another. Similarly, when you are sharing your code base, it might contain so many things. It might contain a front end, database, back end, queue, and all these other things. So basically, the idea over here is that you are putting all of these things that are required to run your website in a box. Okay, so you're putting all the things that are required to run this website in a box, and you're shipping this box to your friend. For example, the source code, the operating system, or like the base operating system, or the database, the front end, back end, and caching, whatever you are doing. Put everything inside a box, and you give this box to your friend. Like, for example, I'm trying to explain it in as simple language as possible. Now, this will make sure that this thing is running on their system. Okay, because everything that is required to run that code sample will also be present in that box. This box, the running instance of your application, where your application, let's say your application is running inside this box, this is known as a container. Okay, so how does it basically work? You have virtual machines. You might have heard about virtual machines. Containers, this might be a new term to you. You might not know what are containers. Okay, virtual machine is basically like you have your infrastructure, like your computer, your hard disk, or whatever, and on that you basically divide the space on your hard disk and install a separate operating system on that. You might have done like something like dual booting your PC or whatever. I did that when I was in high school. So on my same machine I had Windows and Ubuntu installed, for example. So it divides the hard disk space, installs operating systems on it, and then you can have like two operating systems on one machine. But this is like a little bit slow as compared to like creating the hard disk space, adding the entire operating system, then running things on top of it. Containers, on the other hand, you don't need to like divide the hard disk space as such and install an entirely new operating system. No, here what is happening, here you can see separate operating systems are present over here, managed by a hypervisor manages this. So here what is happening in containers, what is happening is that your applications are running in isolated environment. Okay, so imagine your application will be running inside a box, and that box, let's say, it's not going to know what's going on like outside, let's say all the processes that are happening in the main operating system. So on top of your main operating system, applications will be running. Okay, so these applications running in a box, that box, it's known as a container. It's actually a running instance of your application. In that, a container is basically a thing in which your application will be running. Okay, so in this case, a container engine will help us in managing that. One of the containers, one of the tools that helps us in doing this is known as Docker. Okay, so using the same operating system, you can run multiple containers and multiple applications and all these things. Let's move forward. I'll explain in much more detail of how these things are working. Let me start Docker on my PC. Oops, not the Docker website, just Docker. Oops, Docker should be starting anytime now. Not right now. I'll review later. It's starting. So you can download this. You can download Docker Desktop from your like from the website. So let me just see. New window. Download Docker Desktop. Here. Okay, you can download this. Over here. Share the link in the chat. Okay, so this is the link. You can download it. Stream quality, I believe, is 1080. So let me just double check. Yeah, it's 1080. So maybe you can check your settings and stuff. But anyway, let's move forward. So actually, like the containers thing that I talked about, container is basically, you can imagine a box in which your application is running. And this is like an isolated environment. Okay, even though it's running in your operating system, let's say it might not know what is going on outside the box, for example. Obviously, you can communicate with other containers outside the box, do all these things with the addresses and all these things. But it's actually your application running in an isolated environment. Okay, so that is what container is. I'll dive more into it in short, but let's look at the Docker architecture, how this thing actually works. So you have the Docker daemon, which is like the server. You have the REST API. You have the Docker client, Docker CLI, the client, and that is pretty much about it. Okay, this manages the containers and images. We'll look more into what are images, what are volumes, what is network. But in short term, the daemon is basically, it actually listens to the API requests being made through the Docker client and manages Docker objects. Now, I know a lot of words are being said in this sentence, so let's look into it one by one. When I have my terminal open here, let's say you install Docker and everything, and you open up your terminal. Let me full screen this, and let me zoom in a little bit. Okay, so if I say Docker images, so images, you don't know what images are right now. Let's say Docker PS, container running or whatever. Okay, so this is a container running Node Mongo to do application. Okay, this is a container that is here, and this Docker command, basically I made it via the command line tool. You can also make these commands via the GUI, the graphical user interface. Okay, similarly you might know about Git and stuff. So you have the Git CLI. Similarly, we have the Docker CLI. So this Docker client, this is this thing. This is what you use to interact with Docker, and these commands are actually going to the daemon. Okay, so via the CLI, via the API like client, the commands are going to the daemon, and daemon is actually the Docker server that is running. It's like, hey Docker daemon, please make a container for me. Please create 2 containers for me. Please scale the containers for me. Please delete the containers for me. So you communicate to the client, to the Docker server, the daemon, via this Docker command. This is known as this thing, the Docker CLI. Okay, Docker client, this is the thing which you use to interact with Docker. You send the client sends the commands to the daemon. Registries are basically where Docker images are stored. Let's look into what images are. Okay, I will give you a really nice example, and it will make things very, very clear. So imagine that you are cooking. Okay, imagine you are cooking. So when you're cooking a new dish, how does that scenario play out? You have a recipe written on a page or something. You follow that recipe, and a dish is created. Very important example. Please listen carefully. So in the recipe, it will be listed something like you need these ingredients. You need this much amount of ingredients, and this is the step that you need to follow. Okay, and when you follow all these things, when you get all the ingredients and follow the steps mentioned in the recipe, a dish is created. Let's compare that with like the Docker example. So a Docker file, there's a thing called a Docker file. The Docker file basically lists all the things that are going to be required to run my application. Like, your operating system should be Ubuntu. You should run the command npm install. You should then run the command, node server.js. You should have this much amount of resources or whatever. All these things will be listed in a file. The recipe file for my application, basically, that is known as a Docker file. Okay, so in that you specify, I need this, I need that, this is what needs to be done, these are the steps that needs to be performed. Okay, so when you create a Docker file, when you run a Docker file, a Docker image is being created. Okay, so image is basically a file that basically, what is a Docker image? Whenever you run a Docker image, a container is being created. Let's look into Docker image. So a Docker image is basically a file that defines a Docker container. If you are familiar with virtual machines, it's similar to the concept of snapshot in a virtual machine. Let me explain it in much more detail. What is a Docker image? So basically, let's say I want to run MongoDB. Okay, I want to run MongoDB on my machine, or I want to run Ubuntu on my machine. So let me show you how easily and how fast, like this, I will be able to run Ubuntu on my Mac OS. Docker run Ubuntu. That's it. Ubuntu is running on my MacBook in Docker. Docker PS. PS basically means show me all the running containers. So you can see Ubuntu is running, started 10 seconds ago. How fast was this? very fast. So you can see how fast, Docker stuff is. So this Ubuntu thing is basically an image. When I run an image, the application starts in a container. That's basically the idea of an image. Image is just a file that defines what the container will be. Okay, so these softwares like Ubuntu, MongoDB, MySQL, these are very popular softwares. Okay, many people use it. So an image for this is already being created and it's uploaded in an online repository somewhere known as Docker Hub. So for example, if you are at a hackathon, okay, and you want to try out MongoDB, but you don't want to install MongoDB on your system, you can just run a container of it. Just download the image of MongoDB from online, because MongoDB is a very popular tool. People have already created images for that. So image is nothing. Image is just a file. And when you run that file, the application will start. If I run the MongoDB image, MongoDB will start on my computer. Okay, here I am running the Ubuntu image, so Ubuntu will start. So that's about images, that's about Docker files, that's about containers, and that's about Docker. Everything is covered. Okay, images are built in layers. Every layer. So basically, this is a bit of advanced topic. I'll also let me just exit out of it. Not that advanced, but still, like for beginners, let me just see. Docker, Ubuntu, Docker. Let me just copy this only. Show you the IDs. So yeah, these are the hash values. I'll show you more in detail later on when we talk about what layers are and what components are. Don't worry about this right now. Okay, this is just the image ID, the first 12 characters of the hash value. I'll speak more about this later. Don't worry, we are not skipping this. When we look at the Dockerfile example, then I'll tell you what is layer and what is all these things. Okay, cool. Dockerfile, very simple stuff. We already discussed it. It describes the steps to create a Docker image. So Dockerfile, you run that, you will create a Docker image. You run the Docker image, you will create the container. Okay, so basically, so many applications are running in containers. Does Tinder use Kubernetes? You can see around 48,000 containers. Tinder is running on 48,000 containers. So container is just nothing but a isolated environment in which your application is running. Like I was running Ubuntu right now, so as like Tinder and all these other platforms. I saw it over here. Like there's a KubeCon talk, very nice talk. You should check it out. So that's where I got this example. So you can see 48,000 running containers. Okay, so it's very fast, and it's not like you should use virtual machine or containers, or no, it's not like that. It's like it's not a this or that question. Containers run on top of virtual machines. Okay, so you have like your instances and all these things, and on top of that you can use containers and stuff. But let's look into what Docker files are. So Dockerfile, basically simple Docker file. We have some tags defined over here. From Ubuntu means the Ubuntu image. If it will like if you don't have Ubuntu, it will look, the image downloaded. It will look at the Docker Hub and stuff. This is just for documentation purpose. Run this command. So this basically means while my container is being created, please run this command. And when the container is running, run this command. Very simple stuff. So if you're doing something with Node.js, here you will write npm install, and here you will write yarn start or whatever, like node python node server.js or whatever. If you're running Flask, so here you will write something like pip install, and here you will write python server.py. Very simple stuff. I'll show you an example for this later on. Docker containers, we already looked into this. Container is a running instance of an image. This is where your application is actually running. Okay, and you can manage containers via the Docker API or CLI. So we are using it like Docker PS. Okay, so currently I have one container running. I can kill this as well. Docker PS. This one. Docker kill. Oops, not Docker kill. Docker remove. Oh, no such. Okay, one second. Might be doing something wrong. This is it. Okay, it's restarting. There's some problem over here. Okay, it's restarting. Okay, I can do force remove, but don't want to do that right now. Yeah, these are just some commands. So if you delete a container, this is an important point. So basically, when your containers are running, so for example, in the Docker, if I do this thing, let's say this container, let's say any container is running, by default, like if the container stops running, then the data that was stored in that, it will also be lost, which is why we use something called like persistent volumes. Okay, so you can store your data somewhere else, like at a separate disk or whatever. Okay, so entire data will be lost. So make sure, if you're using, this is another session maybe we can have on this stateful applications versus stateless application. This is a few commands. Docker ps will show you the containers that are running. Docker run will run that image. Start will start the container. Kill will kill the container. Remove will remove the container. And inspect will actually show me a little bit more about the information. So if I say something like Docker inspect Ubuntu, so here you can see everything related to the Ubuntu image. So it has like one layer over here. Over here it might be showing some other information. I had some other images as well. So let me just see Docker images. The node mongo to do. Oops, sorry, not this. Docker images. Docker inspect. Node mongo to do app. Docker inspect. So this particular image is built in so many layers. Okay, so I told you that we'll talk more about what layers are and stuff. So in your Docker file, it may use like many applications, right? So these are built on top of each other. So this is basically verified via a hash ID, and each layer has a hash ID. Okay, the reason for this is that when you're downloading this for the very first time, it may take some time. Okay, your image might be, let's say, sometimes I've seen that images go up to like 1 gigabytes or something, or so many images might be there, like size dependent, supporting depending on your internet speed. When you're downloading the images, it may take some time, but when you run that image again and it's already being downloaded, it will verify it via the hash value. So when you run it for the second time, so for example, when I'm running Ubuntu like this, okay, so here I'm running Ubuntu again and again. Okay, Docker run. So it's running very fast because it already has it downloaded and it already calculates the hash and everything. It knows that, okay, this is already downloaded. I don't need to do it again and again until and unless I specify a other version. Okay, so you can also specify versions like this, 16.04. If you don't specify any version, it will take the latest value. Okay, cool. Let's look more into detail of this. Like this is how it actually works. So when you run a Docker command, it will go to the Docker daemon. Docker daemon will be like, hey, do I have an image of this in my local repository? Sorry, in my local system. It's going to be like, no, you don't. Then download it from the Docker hub, download it, start the image, create a container. How do you manage a large number of containers? Let's say you have 48,000 containers are running, and imagine that this is also important point. So imagine that you are running so many containers, and now 100,000 people are using your website. Okay, your website is running in so many containers. Now 100,000 people use your website. So you basically need some sort of a way to scale the containers, like create more instances of your application, distribute that load onto various servers. Okay, another problem you might face is that, let's say, not many people are using your application, and so many servers are running, so you might want to scale down. Another problem you may face is, let's say, some of the containers get corrupted. Okay, your applications were running in containers and some of those got corrupted. You need to restart those. That's also something you might face. Another thing can be you need to update a new application. So you want to update your application basically, and you don't want to, like, let's say, stop all the containers, then update and then restart all the containers. You want to do like a rolling update. That's also another problem. So doing all of these things manually will take a lot of time, okay, and a lot of efforts. It would be pretty awesome if all these things that I just mentioned to you, if we could do this automatically. Like, so there was some sort of an automation provided for that. Comes into picture Kubernetes. So Kubernetes, it's one of the functionalities it offers is container orchestration. Solves all the problems I just mentioned. We'll look more into it in the next future sessions of the DevOps Bootcamp. So make sure you subscribe to the Civo YouTube and press the bell icon, and check out the quiz link in the description as well. But before we move forward with any of the other things, I would like to present Alistair on the stage to share more about container runtimes and how Docker compares with other container runtimes, and answer all the other questions as well. Feel free to ask all your questions in the chat.
Hi, I picked out a few interesting questions we might want to cover now that I've seen going through the chat.
Go ahead.
So one of them was, what if an image is not in Docker Hub? when you run it. Do you want to run through that?
Yeah, if it's not in the Docker Hub, I believe that's going to give an error. So if it's not there, that will give an error. Many times what happens is that for the famous applications, like, that are obvious that, will be containing images, for that, there are going to be like images in the Docker Hub. But let's say you created your own application. Let's say you created a to-do list application. Now that is not a very famous project. You created it yourself, right? So obviously an image for that is not going to be present on Docker Hub. So you can create an image for your own applications via what? Docker files. We just looked into it. So we'll also see an example for that. I created a to-do list application, and I'll show you how I created an image out of that. So if an image does not exist, you can create it via a Docker file.
Yeah. So Docker Hub is an example of an image registry, a big public one with all those common containers. But whilst I work for the companies I work for, they all have private repositories where they push all of their like confidential containers and stuff. So they're basically just a good way of sharing containers, images over the network. Yeah. Another good question that came in was what happens to data when a container restarts?
If it's not persistent, it's I think with it restarting, sometimes that's fine. But if it gets deleted, then the data will be lost. Data will be there if if you stop the container then restart it. I can show an example for that as well. But if the container gets corrupted or deleted, then the data will be lost.
Yeah, I think that runs well on to the next question was what's the difference between starting a container and running a container? And I guess we've kind of answered that where if you had a container running and you issued the stop command, it would preserve the state of that container and then you can start it again later. So say you were working on your laptop in the coffee shop and you turned your laptop off. In the background, Docker would stop all of those containers that were running. You get home, you plug it back in, turn it on, it would start them again. So they would be roughly in the same state you left them. But run would be for start me a new fresh version of this image as a new container. So yeah, some good questions coming through there. We've also just had one. Why did Kubernetes switch from Docker as a container runtime? That's a great question because I have lots of slides on that.
Yeah, that's why I said you can take that one.
So I'm going to just try and press the buttons to make me share my screen. Share screen. Select the window.
Does this mean that container is a runnable instance? It's a running instance of your Docker image. Yeah. There we go.
Wonderful. So yeah, keep your questions coming. Feel free to drop in and ask any questions as we're going along. If you see any cool ones in the chat, because I probably can't focus as much on it now. But basically, I'm going to take a little bit of a step back, maybe from Docker, and focus more on the sort of underlying fundamentals of like how you run a container, why there's more than one container runtime, and what a container runtime actually is, because I think this is possibly the first time a lot of you will have heard that. So a container runtime is basically it's an implementation of what's called the container runtime interface. And that interface is basically a contract between a developer of a container runtime and there's this specification. So if I wanted to write my own container runtime, I would have to do things which meant that I can start, stop, and delete a container, pull, push images, check the status, run commands inside them like Docker exec, where you can actually get live inside the container, check the logs and stuff. So it's kind of like there's more than one. There's a lot, and we'll see them now. So these are kind of container runtimes which are part of the cloud native computing landscape. So cloud native computing landscape kind of we won't get into it now, but there's hundreds and hundreds and hundreds of projects which kind of live in this ecosystem. You'll notice that Docker isn't in here, even though Docker is probably what you think of when you think of containers. And that's because Containerd, the first one there on the list, is actually, it used to be part of Docker, and it was kind of brought out of the main Docker code base, run as a separate project, and then donated to the Cloud Native Computing Foundation. And the reason for that, probably, is that Docker were very early in the container space. And by removing the core container component from Docker and donating that means that everyone else would probably use the same specification, use the same commands for running containers, and kind of follow them. Big question, which container runtime should you use? Well, it kind of depends what you need. And Kunal mentioned that you might be running hundreds or thousands of containers. You might be running one container. You might need to really carefully isolate your services, your applications between almost virtual machines. And there are some container runtimes which work sort of like virtual machines. So they have much more isolation between the two processes. Multiple architecture support, which we probably won't get into, but there's lots of reasons. But why would you, as a developer or a DevOps engineer or a platform engineer, why should you care which container runtime you use? You probably don't, really, unless you're running at scale or you've got specific problems to tackle. Just use the container runtime that comes with. Let's say you're using Kubernetes, use that one. If you're using Docker Desktop, you don't really care. It sits in the background, but it is important to understand kind of what they are and why they exist. So we mentioned Docker a lot. Containerd used to be part of the Docker code base. It was pulled out and created into its own project. And we're going to take a look at like how Containerd came about. So the timelines are kind of in 2016, which is a long time ago now. Containerd was sort of created as a separate project. It was pulled out of the Docker code base, and they kind of lived side by side. And then a little later on, when the code was sort of cleaned up a little bit, it was donated to the CNCF, the Cloud Native Computing Foundation. And this kind of cemented its use as probably the number one container runtime. It's now no longer under the control of the Docker company. It's been donated to the Cloud Native Computing Foundation. It's sort of run on its own, so companies don't have to worry that Docker might take a turn to do something they don't like. They can actively be involved now. Because it's an open source project under CNCF, it gets all of the focus there. And then, it's had a few major releases, 2018, 2019, it graduated. I think was it the first CNCF graduated project, which is like their top tier of project with really good governance, really good code base, very good adoption. So it's kind of like the gold standard of container runtimes. Sorry, anyone who likes other container runtimes. In 2018, Kubernetes kind of adopted Containerd as a proper first-class runtime, whereas before that, Kubernetes always used to use Docker under the hood. So you would go, the Kubernetes would talk to Docker, and then Docker would talk to the container runtime. As of 2018, it went Kubernetes talked straight to the container runtime. So you cut out that Docker section. There's no longer a requirement to use Docker on your Kubernetes nodes. And that kind of, there was a sort of evolution of the internal Kubernetes code base, which is quite interesting. So we're just going to take a quick look at it. So initially, so the kubelet, which is part of Kubernetes, which is responsible for starting containers and managing the container lifecycles, would talk to this custom piece of code called the Dockershim, which was a custom kind of thing written, maintained by Kubernetes that listened and accepted these container runtime kind of calls and commands like Docker run, Docker whatever, and converted them into the equivalent underlying Docker command. So the container runtime might have been run this container, for example, and then they'd converted it into Docker run this container. And then that would talk itself into Containerd. But then when it went GA, we moved to the second part of the screen here, and we essentially removed that custom bit of code called the Dockershim, and we have this piece of code called the CRI Containerd, which basically does the two things that the Dockershim and Docker do in the first one. And then moving forward, this was the major release, Containerd 1.1. That CRI Containerd actually became part of Containerd, and we get even less code. I think if you go to that link and read the blog post, I think it was 30% faster for starting containers. So if you're running a lot of containers, starting them, these kind of things can have a big impact. And then, yeah, there's the adopters of Containerd. So you can see there on the right, Docker, IBM Kubernetes, Google Kubernetes, Firecracker, which is another container runtime, but it uses Containerd under the hood. This may have been updated because I wrote this talk a while ago, but there's lots and lots more people who use Containerd as a container runtime. And yeah, play with Kubernetes on Civo, I suppose. And that's me. Cool. That was a really quick run through of Containerd, Docker, and how those two things fit into Kubernetes. So thanks.
Yep. I also want to make like a really nice announcement. I mean, we did make it already. So we have civo.com/academy. Over there, you can go and you can learn about Kubernetes. We have an entire Kubernetes course with even more modules being added, in the future. And the best part is it's free. It's created by the entire team at Civo. And thanks a lot for the presentation, Alistair. Got a really lot of nice shout outs in the chat. So that's great. All right. Cool. So only thing remaining now is the demo that I was sharing. So maybe you can take a look at the chat, and till that time I can maybe show the demo. Basically, 1 second.
Yes, we've got a question. Are these container runtimes like other Docker hubs? No, not really. So a container runtime is something that runs on your computer or your virtual machine or your server that actually runs. It will pull from a Docker hub type registry, and it will run the containers on your machine. So you can have lots of different, you could even have a cluster with different container runtimes, and then they would all pull from the same Docker hub or the same registry. And the idea with the container runtime is it doesn't matter which one you choose, you should be able to like plug and play those depending on your requirements.
True. All right.
There's a question about,
go ahead. No,
yeah, I'll say there was a question about, we're going to show how apps are created shortly, and I think that's what you're going to do now, which is great.
Yep. So if you want to create your own image and create different containers and talk to each other or whatever, we'll look at a very simple example for that. Let me just share my screen. So this is a simple to-do application. It's using Node.js and MongoDB as a database. So you can see it's just a simple to-do application. And basically the idea over here is, what am I trying to do? I'm trying to create two containers. Okay, listen very carefully. I'm trying to create two containers. In one container, this entire application will be running for my website. And in another container, MongoDB will be running, the database. Okay, and somehow I want these two to communicate with each other. So for this thing, you can use something known as Docker Compose. Now, let's see what are the requirements over here. We need to create two containers, okay? And for creating a container, we need images, okay? So let me know in the chat if we need to create like two containers, one for my database, MongoDB, and one I need for my application. So for which particular container an image would already exist? Anyone in the chat? I think there's a delay. So that is
there is, yeah.
There is a delay. Okay. So I have MongoDB that I need to create in a container, run in a container, and I have my own application that I need to run in a container. So I need MongoDB, exactly. So got a lot of MongoDBs. Not both, because the application that I have created, it's not very popular. Okay, so it does not have the image. The image for this application that I have created does not exist on Docker Hub or wherever, because this is something I have made. This is the code I have written. Okay, but MongoDB is something that many people use, so this will be available. So hence, the image that I will create for MongoDB, I do not need to worry about that. I need to worry about how am I going to create a container for my application that I have over here. For that, I need an image, a custom image. For that, I need a Dockerfile. Let's see what this Dockerfile contains. So since this is a Node.js application, I'm saying from the base node. So basically, I zoom in a little bit. So Node.js, it's going to download the image from Docker Hub or whatever registry, online registry. I'm setting the work directory in my container. So my container will have this work directory. I'm saying copy all the JSON files that contains package in it, copy all of these files that are in my local folder in my container. Okay, this is what this tag is doing. Run npm install. Everyone knows what npm install is, just installing the modules and packages and whatever. Then copy all the source code and everything that I has from the current directory, copy everything in the current directory of the container. Okay, and then export port 3000. This is basically just for documentation purpose. It's not actually exposing anything. It's just saying that, when you're exposing your port over here, it's like port 3000. So when you're actually running this container, that time you would have to expose this. This is just a documentation tag. Okay, so it's saying whoever is running this Dockerfile, make sure you expose port 3000. So basically what is going to happen is that your application will be running in a container, and we access our applications when we run on our local system. If you have done development, we access it on localhost. So basically the idea is that whatever application is running inside the container, I need to access that application to my local host basically. So whenever I go to localhost port 3000, I want it to direct it to my container basically. That is what the port forwarding thing that we'll be doing. Command is basically run this command, node server.js. So when I run this Docker file, okay, an image for this application will be created. And if I share that image, if I upload that image on Docker Hub or whatever and share it with you all, and you run that image, you will also be able to run this file. Let's try to run this. And Docker Compose basically combines two containers into, let's say, like how we can use more than one containers together. So here I'm creating container number 1, container number 2. I'm giving this the name as app, container name app. You can give it anything you like. Build dot basically means give the path of the Docker file. Okay, so for this container you need an image, and since it's my own custom application, I would have to create a Docker file for it. So hence I've said in the current directory there's a Docker file. Here you will pass the path. This is the port forwarding thing that I talked about. Port forward like port 3000 of container to my, I can access it from the local host. Links, which particular other container is linked to this container, Mongo. Okay, so every container may also have its own IP address and stuff. The only change I have made in my code base is this thing. I have added Mongo over here. If you are not adding Mongo, it will be localhost. If you're running it on your local system, it will be localhost. But here, since I'm running it in a container, so it's going to be like, hey, this application is running in an app container, and I basically want to communicate with MongoDB. Where is MongoDB running? It's going to be saying, hey, it's running in the Mongo container. So you are basically accessing this container using the name of this container, the Mongo, this thing. So containers can actually talk to each other using your addresses and ports or whatever. So here we are actually replacing Mongo, the local host with Mongo. Okay, we're replacing localhost with Mongo. Cool. There's a link we have gotten, a really nice link. I'll share it later on. But that is the only change I have made in my code base, as you can see. Okay, nothing major. Just I've changed the localhost to Mongo. That is it. Because imagine, visualize this. This will be running in a container. So in container, it will not look for localhost running MongoDB. So it's not going to say MongoDB running at my container's localhost port 27017. It's going to be like the Mongo container is running it. That is what we have over here. And then we're defining the Mongo container. Name is Mongo container. Image, well, Mongo image. It's going to take it from the Docker Hub or whatever, and then port forwarding. Okay, let's try to start this thing. So if I go to documents, I can go to web projects. Projects.
So we've had a question. Can someone explain restart always in the file?
I think it means when it which one? This one?
Restart always. Yeah. So
yeah. Go ahead.
If the container exits for some reason, it will restart automatically. You can have. There are other options. Never. Can't remember the other ones, but yeah, it's about if the container dies for some reason, will it restart automatically?
So the command we're going to be using is Docker Compose build. Let me show you, something awesome. That this code that I wrote was actually in some other machine 2 years ago, and this is going to run it on this system very easily. It's, you can say I'm running it for the first time after a really long time. I deleted the previous stuff, so it's actually downloading and everything. So you can see step 1 on 5 from Docker node. So this thing, this thing. Then it's going to do run, work directory, step 2 of 5, step 2 of 5, then copy, then run npm install, copy, run, and you can see it's going line by line. It's creating the Docker image and stuff. And I can say Docker compose up. Starting MongoDB should run because it's Docker. That's the entire point. If it does not run, that would not be nice. Okay, let's try localhost 3000. How cool is this? Like I wrote it 2 years ago, and now yeah, my node application is running. Pick up books or whatever, and you can done it. You can delete it. You can reset it. Hey, reset it. Then you can see something like pick up files, go to somewhere or whatever. Okay, now what I can do is, if you want to see all the containers that are running, if I do docker ps, you can see 2 will be running. One, my node application, and another is MongoDB. I can see it's port forwarding it to port 3000 and port 27017 because of this thing. Okay, very simple stuff. And one more thing I wanted to share was, yeah, here you can see I'm getting all the logs and stuff as well. Let me try to stop this thing. Okay, let's try to, obviously this will not run now because container is not running. But when I restart this again, you will see that the data will be still there. The data will still be there because it's not deleted. Container is not deleted. Container is there. It's just restarting now. So you can see data is still there. But let me try to delete the container. Okay, let's try to delete the container and let's restart it again. So docker ps. Okay, I can say docker ps -a. It will show the hidden ones. So where is Mongo? This one, I can remove this. Docker remove this. Now that container is gone. And when I run this command again, let's say docker compose up. That's gone. This is the example we showed previously, that in containers, if your container dies or whatever, the data will be lost. So we can have a separate session on like stateful versus stateless applications, when you might want to use this functionality, when you might not want to use it. This will make much more sense in like Kubernetes. You won't be running Docker as it is like this. You will be using some sort of orchestration like K8s or Docker, what's it called? I forgot the name. The Docker equivalent of Kubernetes. What was it?
Docker Swarm.
Docker Swarm, yeah.
Yeah, so there's actually a question come in. As a beginner, should you be learning about Kubernetes or Docker Swarm?
I personally don't know much about Docker Swarm. I know like commands and stuff. I personally know more about K8s. But that's just like, I don't have like much. I think K8s, but I don't really have a solid answer to that. I think like K8s being used much more or something. But related to like technical advantages, maybe you can share about that.
Kubernetes has got far more community support, commercial support, features. There was this kind of container orchestration war between the two of them. We weren't sure who was going to win, but Kubernetes seemed to just pull ahead. Doesn't mean there's anything wrong with Docker Swarm. It just doesn't have the features that a lot of people want. But if you're learning, if you're getting started with Docker and you want to play around, Docker Compose, which we've just been playing with, keeps everything local on your machine. If you install Docker Desktop, you get it out of the box. It's probably the easiest place to start, because container, Kubernetes, Docker Swarm, they get quite complicated because there's lots of different computers and networks, and there's lots of stuff going on. So if you're just starting out, Docker Compose is probably the easiest. We've had a question: what are the things you must learn before starting to learn about Docker? I think there's a few people try to answer it in the chat, but if you want to give your thoughts.
Linux commands, and if you know a little bit of development, that's nice because then you can try it out hands-on and stuff. But I think there is no hard prerequisite. Just like in this session you saw, even if you did not know much about containers or anything, you were able to start about it with this session only. So no as such hard requirement, but just like some basic networking, how IP addresses work, and what is a port, what are IP addresses, basic networking stuff, basic Linux commands and stuff. I would recommend learn on the go. So don't feel that you can't learn something
Yeah.
if you don't know much about it. Learn on the go. Docker you can get started, but for Kubernetes, obviously learn about containers first, and then start with K8s.
Yeah.
Yeah.
Ask lots of questions. It's how I picked it all up to begin with. I started out, didn't know anything. Started by just doing Docker run something like you did at the beginning, Docker run Ubuntu, and go, oh, what's that done? Why? How does it all work? Ask lots of questions. Reach out to people. Join the Civo Academy, which is free, which civo.com/academy, I think it is.
People are
And then
asking
there was
about
a question.
K3s and K3s and K8s. So just we have a separate session on that. So maybe you can hold on to that. But there's a video on K3s on the YouTube, the Civo YouTube channel. So you can check that out. But do not worry, we have an entire session on K3s versus K8s in the DevOps Bootcamp. So yeah, make sure you subscribe and yeah, stay tuned. You were saying something, Alistair?
Yeah, there's a couple more questions that I thought might be interesting. Someone's asked, what about building and running containers on Windows, Mac, ARM, Raspberry Pi? Do you want to take that?
I think I haven't used it on Windows, but I know like for Kubernetes and stuff, you do need like a Linux instance in order to run your Kubernetes pods and resources. I think yeah, definitely there is support in Windows as well. And what was the next question?
Well, just on that as well, the every image you build will be built specifically for an architecture, whether that's a CPU or a machine. Because when you run it on the remote, so if I built one on my Linux machine here and pushed it up to the Docker Hub, and Kunal pulled it and ran it on his machine, are you running an Intel, Matt?
I'm running an Intel. Yeah.
It would work, but if I built one on my Linux machine here and pushed it up and tried to run it on the Raspberry Pi, because the Raspberry Pi uses an ARM chip, which is a different CPU inside it, you'd find that it wouldn't work. So if you are getting started and you've got like Raspberry Pis that you're using to play around with Docker and Kubernetes, you need to be careful that the image that you're using also supports that other runtime.
In Windows, you have like something like you're mentioning in the chat as well, WSL. You can try that. It works very nicely. And yeah, that's true. The images are dependent on the operating system.
Yeah, and the Windows Docker desktop actually runs a virtual machine, which runs Linux, which then runs them under Linux things. There's one last question which I picked out while we were going through Docker Compose. Using links in your Docker Compose file, does that mean you don't need to specify a network for your containers to share? I think the answer is yes. It creates the network and it joins both of them together. So this is quite an advanced topic again, because there's multiple networks going on within Docker and containers. So they create their own like mini local internet, and they all attach to that, so they can talk to each other directly. But unless you use the expose directive and mount a port in your Docker Compose file, you can't hit it from you can't even call them from your computer.
If you don't want to write it in a file, then you would have to expose it via the command line. That is also an option. So while you're creating a container, you can expose it over there. But that is not like a good practice. All the things, if you're doing it via files, that's good practice. But as I mentioned, you won't be running containers like just in Docker. You're going to be using some sort of orchestration. So we'll look more into it in the future sessions. Cool. I believe that was it, and we are also about time. So one last thing I want to share is that please make sure you check out the channel. We have some amazing content coming up, and check out the academy. It's civo.com/academy. You don't even need a credit card to get access to it. Just sign up for free and start learning. That's it. So civo.com/academy. Please check it out. Kubernetes resources, and there's a quiz for this session in the description. So it's a Google form if you want to test out your knowledge. what you learned in this session, check out the link in the description. You can learn a lot from there, give the quiz, and we'll reach out to some people related to swag or whatever, subject to availability. And last but not least, subscribe. And if you want to write a blog about this session to enhance your learning, that'd be great. Writing blogs is very great way to understand the concepts. 6 on 10 is very nice. It's fine for first session. You got 6 on 10. That's correct. That's good. No worries. So yeah, do check out the links in the description, and join the Civo channel, join the Civo community. Check us out on Twitter. All the links are in the description, and we will see you in the next one. Alistair, do you want to share something?
There's a question about slides. Are we going to share slides in the channel description?
Yeah, I can share those. Yeah, I'll share.
Yeah, I
those.
can share mine as well. All right, cool.
Cool.
Well, thanks
All right,
for having me.
nice.
I'll see you on the next one.
Bye.